Welcome back. Now we will discuss about the factors affecting on the combustion phenomenon or combustion process. In previous lecture we have discussed about the combustion in SI engine, and that combustion process is divided into three stages, that is ignition lag, next flame propagation, and last one is flame termination. So this ignition lag, flame propagation and flame termination, that depends upon some factors, that is pressure inside engine cylinder, temperature, residual gas. So what is the effect of these factors on this total combustion process? Now first the factors affecting on ignition lag. So first parameter is temperature and pressure. So when the pressure and temperature inside engine cylinder increases, the ignition lag reduces. So why the ignition lag reduces? As the pressure and temperature inside engine cylinder increases, the pre-combustion reaction takes place or carried out fastly. That means whatever the time is there, that time decreases. That means whatever the instant at which high intensity spark is given and instant at which tiny flame appears, so this time or that gap decreases. That means ignition lag or delay period reduces. Second is compression ratio. So what is the effect of the compression ratio on ignition lag? So when compression ratio increases, both pressure and temperature inside engine cylinder increases, and as the pressure and temperature increases, ignition lag reduces. That means with increase in compression ratio, ignition lag or delay period decreases. Next parameter or next factor is speed or turbulence, that is engine speed or turbulence inside engine cylinder. So turbulence is directly proportional to the engine speed. So with increase in engine speed, ignition lag reduces, because as the speed increases, that means pressure temperature inside engine cylinder increases, and as the pressure temperature increases, ignition lag reduces. Next one is electrode gap, that means vicinity of spark plug gap. So electrode gap plays an important role to establish the nucleus of the flame. So if the gap is too small, quenching of the flame nucleus occurs. So lower the compression ratio, higher is the electrode gap required. So the moderate electrode gap is required for the efficient combustion. Moderate electrode gap is required for the efficient combustion. Too small or too large gap creates the quenching of the flame nucleus. So for that purpose, moderate electrode gap is required. Next parameter is chemical nature of fuel and air fuel ratio. So this ignition lag is higher with the fuels having higher self ignition temperature. Self ignition temperature means the temperature at which the fuel gets auto ignite without any spark or without any supply of energy. That fuel gets auto ignite, that temperature is called as self ignition temperature. It has been found that ignition lag reaches the lowest value at the slightly richer mixture than the chemically correct mixture. For the slightly richer mixture, the ignition lag is low. Next factor is residual gas. So what is the effect of the residual gas on this ignition lag? If the percentage of residual gas increases, ignition lag increases. Residual gas means after combustion whatever the smoke is there, so always some amount of smoke is present inside engine cylinder, and that is called as what? Residual gas. So this residual gas mix with fresh charge and increases the delay period. If the percentage of residual gas increases, ignition lag increases. Next is intensity of spark. So as the intensity of spark increases, ignition lag reduces. Spark intensity, if the energy of that spark is more, that pre-combustion reaction takes place fastly. That means ignition lag decreases. So these are the number of factors which affect the ignition lag process or ignition lag. Now similarly, these factors also affect on the flame speed or flame propagation. So first factor is temperature and pressure. So as the temperature and pressure increases, what happens? The flame speed also increases. That is, flame gets propagates fastly from nucleus of combustion towards end of combustion chamber. Next is compression ratio. As the compression ratio increases, flame speed increases because pressure temperature increases. Next is turbulence. So as the turbulence inside engine cylinder increases, flame speed also increases. Next is mixture strength and fuel air ratio. For a slightly rich mixture, the flame speed is more with increase in fuel air ratio. Next, engine speed. Flame speed increases with engine speed. So as engine speed increases, pressure temperature inside engine cylinder increases, flame speed also increases. That means those parameters increases the pressure and temperature inside engine cylinder. So same parameters also increases the flame speed inside engine cylinder. That means those parameters reduces the delay period or reduces the lag. Same parameter or that parameters increases the flame speed. Next one is engine size. The size of engine does not have a much effect on the rate of flame propagation. That means the flame propagation rate does not depends upon the size of the engine. So these are the number of factors which affect the main two stages of combustion, that is combustion process, ignition lag and flame propagation. So this is about factors affecting on the combustion phenomenon.